Hi, welcome to part 6 of building your own Hopper 6502 single board computer. In this part, we're going to talk about the P of CPLD, which is programming your programmable logic device. So I use either one of these for doing the address decoding or the glue logic of your little computer. For a little background, in 2023, I first did this on my first design using a CPLD to do the address decoding. So it takes as inputs the address lines and the clock line of the 6502, and as outputs is basically the chip enables for the RAM, the ROM, the parallel port, the serial port. And the RAM has two because it's got read-write and also chip select. So output enable on the RAM is the read-write. Yeah. Okay. So I've already published this long-form justification of why, the motivation of why my address decoding is different to Garth Wilson's, for example, or Ben Eater's, how they do address decoding with logic chips. And I'll put a link in the description to this little article on Hackster, so that you can get into the gory details of why I did this and what the advantage is in terms of I chose to map my ports onto the zero page. So this light blue, this 256 cell grid is the map of the zero page for Hopper. And the light blue ones right at the end is where I've mapped the serial and parallel ports to. And I used there's no waste, there's no unused bytes. You could say these two are unused on the right because my 6850 only uses 2 bytes. But if you're going to put in a 6551, you're going to need the other 2 bytes as well. So I left it so that Hopper could run, not on this board, but so that you could use the, a 4-register ACIA with it instead of a 2-register ACIA. And then the VIA, the Versatile Interface Adapter, I haven't used all the registers yet. I haven't used all the timer registers, but they're available should they be needed, right? So that's what this chip does. It's for mapping your address space to your ROM, your EEPROM, your RAM, and your I/O chips. Right. If you want to know more about the specific implementation on this device, you can go look at the schematic. Where do you find the schematic? So here in the schematic on the first page, it's got the detail of how it's broken down on this machine. And it mentions the Atmel 22V10 with 10 macro cells, but it applies just as much for the Lattice GEL 20V8. They're pin compatible. The V10, the 10 has 10 macro cells, the 8 has 8 macro cells, but you can fit the same program works in both of them. So you can do more with the 10. The 10 can be more granular if you wanted to, but I haven't taken advantage of that yet. Okay, so where do you find the schematic? If you go to GitHub, under the Rev 1.2, under the single board computer, specifically under the Rev 1.2, there's an entry here for the schematic. You just download the PDF. Also in that, under that same folder in GitHub is the bill of materials. And I've included things on the bill of materials that aren't strictly speaking bill of materials, like the download links for WinCUPL, which is the tool we use to create these programs for CPLDs. Also in the same folder structure is a CPLD folder. Let's switch to that. So in the CPLD folder, I've actually pre-built the ones you need. So if you want to be more creative with this in future and do your own thing, you can install this Atmel's CPLD tool. And my version of the project is this one here, 6502 SBC PLD. And all you do to switch between the two devices is you copy one of these into the device space. So this tells it which device to build for. And it will build different programs for the two different devices. But like I said, you don't even need to do that if you're just building my default version. If you're building my default version, you just use one of these files. And you can find them, again, when you've installed for Windows, as per the earlier video in this series. You go down to projects, you go to 6502 SBC, and then you look under PLD, and there it is. Right? And the two files you want, they're not actually in this folder. They're in the later one I've committed. There's two folders. I can show you what they look like under my version here. Same idea. Source, projects, machine, and then PLD. And under my folder, you're going to see in the new one, you're going to see these two newer ones. These two. Yeah. So the one for the 22 V10 and the one for the 20 V8. There you go. All right, so now you know where to find them. Let's have a look what you do with them. Okay, so when you've got one of these, you will have installed their software, and there'll be a link in the packaging to show you where to get this software from, the XG Pro programming tool. So that's this tool here. On this tool, you're going to have to choose which device you want to program. And the way you find it is you choose either Lattice or Atmel, and you choose on this little drop selection here, you choose PLD. So let's do which one should we do first? The Atmel one? So let's do the Atmel one first. Okay. So I've popped one of these in my in there. You can see it's on that high end there, little notch on that end where the light is, right? So let's choose it out of this list. So that's the 10 macro cell, the 2210B, that one there. Okay, so we've chosen our device. Now we go to load here. And again, we browse to that same folder under projects CPLD, and we choose the 10 macro cell version, the V10 one. Open that. You can see the program's been loaded in here. And then you just press program like that. And it programs it like it would program an EEPROM. That's not good. Verify views. Didn't like that, did it? V10B. Huh. So maybe I didn't put it in properly. Let's check. Oh. All right. I guess it's a good reason I tried this. My label on actually my label is correct. Let's have a look. So it's upside down there, but you see the C on the end. Okay. That's the B. Let's go to the C. There we go. So it does really matter which device you choose. So let's try again. Oh, I forgot to load. When you change devices, you need to reload the program. So V10 there. Right, so it really does matter that you get the, C or B made a difference in terms of actually programming it correctly. Good demonstration, actually, of what's going to go wrong if you pick the wrong device. And there's a lot to pick. There's a lot to choose from. So yeah, and don't worry about the other packages. Those are just different packaging. Just choose the first one in the list, the first of the C's. Yeah. Okay, let's see if I can do a better job of programming the other one, the smaller one, the Lattice version. So let's have a look at that again in the device. So there, notch at that end, pin in the high slot where that is. Okay. So now we have to go choose a different device. So this is going to be a Lattice device, and let's see, it's the B version, GEL, and it's the one with 8 macro cells, GEL, that one. And again, I'm going to need to reload. So I'm going to go load the 8 macro cell version of the program. And there we go, and we program it. There you go. If you choose the correct device, you actually get good results. Right, so obviously I could demonstrate it that works on my board right now, but you don't have a board that works right now, so there's no point in doing that, and we'll do it later. It goes over here, and then the notch is to the left there, as you can see. Right. Let's go have a little bit. That's all you really need to know, is like find the correct version in the repo tree and program it with this guy onto your device. But if you want to look a little further how it all works, you can install WinCPL, which I've said in I list it in the bill of materials page. So at the bottom of the bill of materials page, it says software. I do list it there. And then you can open my programs as well and go and see how you program one of these things. Input pins, output pins, and then this is the logic here. That's, so ROM is just ROM and RAM. Between ROM and RAM, it's basically just address line 15. First, bottom 32K, top 32K. And then RAM I've programmed as it's the bottom 32K, but not the VIA and not the ACIA. RAM also has a second, well, that's the output enable for the RAM. And then the chip select includes the clock, because you want to do it on I think the second half of the cycle, so that the chip has long enough for the address to settle. So the clock is one of the inputs there. And then for the VIA and the ACIA, it's 0 page and then very, very granular address for down at the bottom of the 0 page, so I don't waste any bytes on the 0 page. So with this addressing mode, you don't have to waste like 4K of the address space or 2K of the address space just to put a IO chip there. Anyhow, that is how it works. Oh, and one more thing. Once you've programmed your device, in this article of mine on Hackster, I describe how I tested it initially. So using a breadboard and just using resistors for the inputs, so to high or to +5 volts or to ground, and using LEDs. They've got inline resistors as well, so they don't draw too much current on the outputs. So I could manually program an address in here to verify that my program was working as I expected it to. So this is a fun exercise to do if you don't have your board up and running and built yet, or you get this component first in the mail and you want to play with it, is to go and just manually test that the program is what you expect it to be using a breadboard. Very good. Thank you for watching. There'll be another similar video later in the series on how you program your EEPROMs.